Hello everyone and welcome to the BCG or Business College Government channel. And today we are going to talk about the transportation model. So what is a transportation model? This is a special type of linear programming which is used for helping resolve distribution and location decisions to find the least costly means of moving products from a series of sources to a series of destinations. So what now is in the transportation model? So we have number one, the origin points or where the products are coming from. Number two, the destination points or where the products are going to. The third one is the supply or the capacity per period at origin points. The fourth one being the demand per period at destination points. And lastly, the costs to ship from each origin point to each destination point. Now, here are some rules to remember when doing the transportation model. Let us just wrap our heads around first that the goal of any linear programming is to get the optimized solution, either to get the maximized profit or revenue or the minimized cost. And since we're dealing with shipping cost here, we have to get the lowest cost to supply the demands. The first rule in doing the transportation model is to use the m plus n minus 1 rule. So what is this? This is the number of cells that should have a value allocated to them in the table, which will be shown in a little while. Where m is the number of origin points or the number of rows, and n being the number of destination points or the number of columns. The next rule we have to satisfy is supply should equal to demand, just like in economics. Supply comes from the origin point, while the demand comes from the destination point. Now, here are the steps to solve the transportation model. The first step is to set up the table with the necessary information, just as what was mentioned before: the origin point, the destination point, the supply per period at origin point, the demand per period at destination point, and the cost to ship from origin point to destination point. After which, we have to allocate the values into the cell to develop the initial solution. And don't forget the m plus n minus 1 rule. Also, the supply should also be equal to demand. And finally, after setting your initial solution, you have to solve to get the optimal solution for the problem to determine the minimum cost of the whole transportation model. Now, we have a sample problem with the following given information. We have a supply total of 700 where the sources are from 1. Manila of 100 units, 2. Cebu of 300 units of supply, and 3. Davao for 300 units of supply. The demand is also 700, which means the supply and demand for this problem is equal. And the demand comes from, or the destination points are, Hong Kong for 300 units, Taipei for 200 units, and Jakarta for 200 units. We are also given a table with the following cost. From Manila to Hong Kong, that's $5 shipping cost. From Manila to Taipei, that's $4 shipping cost. And from Manila to Jakarta, that's $3 shipping cost. Next, we have Cebu. So from Cebu to Hong Kong, that's $8 shipping cost. From Cebu to Taipei, that's $4 shipping cost. And from Cebu to Jakarta, that's $3 shipping cost. Now, from Davao to Hong Kong, $9 shipping cost. From Davao to Taipei, that's $7 shipping cost. From Davao to Jakarta, finally, that's $5 shipping cost. So now, let's review. The first step is to set up the table with the necessary information. Basically, we have to put those that make up the transportation model into the table. And here is how it looks like. As you can see, the left side, the one below from, shows all the supply or origin points, which are Manila, Cebu, and Davao, with a factory capacity of 100 for Manila, while both Cebu and Davao have 300 worth of capacity for their factories respectively. And from the right of 2, we have the destination points, which include Hong Kong, Taipei, and Jakarta, with a warehouse requirement of 300 for Hong Kong, 200 for Taipei, and 200 for Jakarta, which gives you a total demand of 700, which is also equal to the total supply. You can also see the shipping costs from each origin point to each destination point in the table, which has been previously given in the problem. Now that we have done the table, we may now proceed to the next step, wherein we allocate the values into the cell to develop the initial solution. And don't forget the m plus n minus 1 rule. So here's how it's going to happen. But before that, let us discuss now the 3 ways to develop the initial solution, which include the northwest corner rule, which starts from the upper leftmost cell, the intuitive lowest cost method or the greedy method, which starts at the cell with the lowest cost, and the Vogels Approximation method, which starts with the largest opportunity cost or loss. So first, we have the northwest corner rule, and here are the steps to do the northwest corner rule. The first step is to start in the upper left-hand cell or the northwest corner of the table and allocate units to the shipping routes as follows. So the first one is to exhaust the supply or basically the factory capacity in the table before from the topmost row before moving down to the next row. Next is to exhaust the demand or the warehouse requirements of each column before moving to the next row. And lastly, check to ensure that all supplies and demands are met. So let's now go back to table 1, which we just solved a while ago. So applying the northwest corner rule, we start with the box between Manila and Hong Kong with the supply of 100. And since the factory capacity for Manila has been met, the boxes of Manila to Taipei and Manila to Jakarta will be left blank. Now, let us move on to the second step, wherein we have to exhaust the demand of the first column, which is the Hong Kong, which has a warehouse requirement of 300. So for us to meet that, we have to now move down. So now we proceed to the box between Cebu and Hong Kong. So based on what we can see, Cebu has a factory capacity of 300. However, since Manila has already supplied 100 units of Hong Kong's demand, all Cebu needs to supply is simply 200 units to Hong Kong. Now, since the demand for Hong Kong has been met, the box for Davao to Hong Kong will be left blank so as not to oversupply the demand. Now let's go back to Cebu, which only has 200 units that have left the warehouse. So to move on, let's now move to the next destination, which is Taipei. And since Taipei needs 200 units, Cebu can only supply 100 units, we will just put all of the Cebu's supply to and give it to Taipei. That now gives Cebu a remaining supply of 0. However, Taipei's demand has not yet been met. So where will we get the source? We will now get it from Davao, since Davao is the only source that can provide their demand. And now looking at our supply and demand, Davao still has a supply of 300. However, Taipei only needs 100 units. Therefore, we just place the 100 units in the box between Davao and Taipei, which meets the demand for Taipei. And finally, Davao to Jakarta. With Davao having 200 units left and Jakarta requiring a demand of 200, we will just have to put the remaining demand and the remaining supply into the box between Davao and Jakarta to complete the table. Now, to check the m plus n minus 1 rule, we have to count the number of columns. So, for this table, we have 3 columns, and we also have to count the number of rows, which is also 3. So, the m plus n minus 1 rule gives us that 3 plus 3 minus 1 is equal to 5. So, that 5 is the number of boxes that should be filled in the table. And as we can see, there are already 1, 2, 3, 4, 5 boxes that have been filled, which means that we have satisfied that rule. And now that we have satisfied both rules, we can now compute our initial shipping cost based on the table that we have just made. So, the first one, we have Manila to Hong Kong. So, the tubs shipped is 100 units with a cost of $5 per unit, which gives us a total product of $500 for that segment. Next, we have Cebu to Hong Kong. So, from the table, we see that 200 tubs were shipped and the cost per unit is 8 per unit, which gives a total cost of $1,600. And doing it again and again, and we have a total of $4,200 of worth of shipping cost. So, just a note, this is just an initial solution. Although it is a feasible solution, our goal, again, since this is linear programming, is to optimize further to get the lowest cost alternative for this problem, which we will solve in a little while. But now, let us now move on to the intuitive lowest cost method or the greedy cost method to get your initial solution. So, here are the steps. The first one is to identify the cell with the lowest cost. Next is allocate as many units as possible to that cell without exceeding supply or demand. Then cross out the next row or column or both basically that is exhausted by this assignment. Find the cell with the lowest cost from the remaining cells and repeat the steps 2 and steps 3 until all units have been allocated. So let us go back to the blank table which we did initially before we did the northwest corner rule. So for the intuitive lowest cost method, we have to identify the lowest cost. So we have the lowest cost of 3. However, both Manila to Jakarta and Cebu to Jakarta have $3. So the rule here is to get to put it in the topmost portion, which is the Manila to Jakarta segment. So looking at Manila's supply, which is 100, while Jakarta's demand, which is 200, we have to exhaust all of Manila's supply to Jakarta. So Jakarta now has 100 units of its demand met, and it only requires 100 units left. And now let's look at the next lowest cost, which is, as we have mentioned a while ago, Cebu to Jakarta. And now Cebu will now fill the remaining demand for the Jakarta segment. So we put 100 units between Cebu and Jakarta to meet the demand of Jakarta. So that gives Cebu only 200 units of supply to other locations. And we continue the process by looking for the next lowest cost, and we have $4. So both Manila to Taipei and Cebu to Taipei have the same lowest cost amount. However, since the Manila supply has all been exhausted, we just have to put or consider the Cebu to Taipei segment. And since the Cebu can still supply 200 units and Taipei exactly needs 200 units, we will just put 200 units to the Cebu Taipei segment. And finally, since both Manila and Cebu supplies have been exhausted, while Jakarta and Taipei's demand has been met, we only have one box left, which is the Davao to Hong Kong segment. We will just place all 300 units there because that is both the demand and supply for the origin point Davao and the destination point of Hong Kong, respectively. And again, this is just an initial solution. We will optimize later the initial solution to get the lowest cost alternative. Now, let us proceed to Vogels Approximation method, which requires us to get the difference of the two lowest costs, also known as the penalty, or the opportunity cost or opportunity loss in each column and each row. So let's now go back to the table that we have just set up a while ago. To start off, let's look first at the row of Manila. So we have to get the second least cost and the least cost, after which we get their difference to determine the penalty. So for Manila, we have 4 minus 3, which is equal to 1, because these are the two least costs for that row. Next, for Cebu, the same case, 4 minus 3 is equal to 1. While for Davao, since the second lowest cost is 7, we have to use that and deduct it to 5 to get a penalty of 2. Now, let us move to the column of Hong Kong, and we have 8 minus 5, which is 3. Then for Taipei and Jakarta, since both their second least cost and their least cost is the same, they both have a penalty of 0. And since Hong Kong has the highest penalty, we will now assign maximum units to where the cost is minimum. And in this case, the origin point with the lowest cost is Manila. Therefore, we exhaust all the units that Manila can give, which is 100, to Hong Kong, which has a demand of 300. And since Manila has already exhausted all its supply, we will now disregard the row of Manila. Now, repeat the process of computing for the penalty. Now we have Cebu of 1, which is 4 minus 3. Davao has a penalty of 2, which is 7 minus 5. And then Hong Kong, since still has a demand which is unmet, we can continue computing with the remaining boxes, which is 9 minus 8, which gives you 1. And then 7 minus 4, which gives you 3 for Taipei, and Jakarta with penalty of 2, which is 5 minus 3. And with that, the highest penalty now is Taipei with a penalty of $3. And as applying the rule a while ago, we assign maximum units to where the cost is minimum. And in this case, we have the Cebu to Taipei segment, which has a $4 shipping cost. And since Taipei only has a demand of 200, compared to the supply of Cebu, which is 300, we simply put the lower one, which is 200, to that box and repeat the process. Now, both the Manila row and the Taipei column is now not available since the supply has been either exhausted or the demand has been met. So let's recompute. For Cebu, the row Cebu, we have 8 minus 3, which is equal to 5. Then for Davao, we have 9 minus 5, which is 4. While for the column of Hong Kong, 9 minus 8 is equal to 1. And Jakarta, which has 5 minus 3, which is 0. And in this case, we can see that Cebu has the highest penalty. And we assign maximum units to the one with the minimum shipping cost. And in this case, the one to Jakarta, which is $3 shipping cost. So we assign the remaining 100 units that Cebu can supply, but the demand for Jakarta is 200. Therefore, the demand for Jakarta is not yet complete, and we now have to repeat the process, wherein now Cebu is also having a not available penalty because the supply has all been exhausted. Now, we recompute for the remaining penalties for those demands or supplies which have not yet been met. And let's start with Davao. So for Davao, we have 9 minus 5, which is 4. And for the Hong Kong column, we have 9 because there's nothing to deduct 2 anymore because the others have already exhausted. And for Jakarta, we also have 5, which is identical to the case of Hong Kong. And since Hong Kong has a penalty of 9, we will now exhaust the remaining demand from the supply of Davao, which is 200. And finally, the remainder will go to Davao to Jakarta segment, which has 100 units left and 100 units of demand to be met. And applying the m plus n minus 1 rule, this is now correct. And that is your Vogels approximation method initial solution. And again, since this is an initial solution, we have yet to optimize it to get the final solution. Now, let us proceed to the last step to get our optimal solution. So, there are 2 ways to achieve optimal solution. The first one is the stepping stone method, while the other one is the modified distribution method, also known as MODI. So, let's start with the stepping stone method. So, here are the steps to compute the optimized solution using the stepping stone method. The first one is select any unused square to evaluate. After which, beginning at this square the square that you chose, trace a closed path back to the original square via squares that are currently being used. And beginning with a plus sign, at the unused corner, place alternate minus and plus signs at each corner of the path just traced. After which, calculate the improvement index by first adding the unit cost figures found in each square containing a plus sign and subtracting the unit cost in each square containing the minus sign. Repeat steps 1 through 4 until you have calculated an improvement index for all unused squares. If all indices are greater than 0, you may have just reached an optimal solution. So here's how it goes. So using our initial solution, which is from the northwest corner rule, let us now start using the stepping stone method. So let us start with the unused box, which is the Manila to Taiwan segment. Then to form a box, we have to go to the left to the Manila to Hong Kong segment, and down to the Cebu to Hong Kong segment, and to the right to the Cebu and Taiwan segment to form a box around that unused portion. And from that, we apply step 2 with the alternate plus minus signs, wherein the unused portion or unused box will have a plus sign and alternate until it goes back to the unused box. So for that segment, we have an improvement index of plus $3. And repeat the process to the other boxes until all of them has been filled up. So here is the summary of improvement indexes. And from this one, we can see that Davao to Hong Kong index has a negative index. So with that, we now proceed to the next set of steps. So if there is an improvement that is possible, we choose the route or the unused square with the largest negative improvement index. And on the closed path for that route or route, select the smallest number found in the squares containing minus signs. And lastly, add this number to all squares on the closed path with minus signs and subtract it from all squares with a minus sign. So here's how it goes. So in the case of Davao to Hong Kong, we do a loop around it, around the used squares. So we do it just like the one a while ago, wherein we go to the right to Davao to Taipei, next to Cebu to Taipei, to Cebu to Hong Kong, until we go back to Davao to Hong Kong. Now here's what's going to happen next. You will have to add 100 units on the route of FA, or basically Davao to Hong Kong. Then subtract 100 units from routes FB or Davao to Taipei, and add 100 units to route EB or Cebu to Taipei, and lastly subtract 100 units from route EA or Cebu to Hong Kong. And here is now the new setup of your table. And then we have to repeat the process by computing the improvement indexes of each box, specifically the unused box, until all of them have become positive. So in the next table, we have Cebu to Jakarta with a -1 improvement index. And then we have to repeat the process by forming a loop around that negative improvement index and add that number to all squares on the closed path with plus signs and subtract it from all squares with a minus sign. And that gives you the new table, which gives the Cebu to Jakarta segment additional 100 units. And if we repeat the process, we will see that all the improvement indexes are now positive, and we now have your optimal total cost of $3,900. Next, we proceed to the modified distribution method, or the MODI method. So the steps here now are as follows. Number one, you have to generate a feasible solution or an initial solution, just like the one we have prepared a while ago, which can be either the northwest corner rule, the greedy method, or the Vogels approximation method. After you have done that, you can now assign row and column indicators to each row and column of the transportation tableau. So you have to let R sub I be the indicator value assigned to row I, and let K sub j be the indicator value assigned to column J, wherein both values of I and j can range from 1 to any number or integer. So as an example, let me show you now the initial solution that we have done a while ago for the northwest rule, or the northwest corner rule also. So the first step is to assign row and column indicators to each row. So here is how it looks like. So for Manila, we have R sub 1, Cebu we have R sub 2, Davao we have R sub 3. While for Hong Kong, we have K sub 1, and Taiwan K sub 2, and Jakarta K sub 3. The next step now is to compute the values of R sub I and K sub j, which have a sum of C sub ij whenever X sub ij is greater than 0. So what does this mean? Specifically, the C sub ij and the X sub ij. So the C sub ij is the cost per unit transportation, or the shipping cost per unit, while the X sub ij is the amount of units to be shipped from source I to destination j. Take note, only focus on the cells that have shipment units. So now let's apply this. R sub I plus K sub j is equal to C sub ij. So each box, each filled box is the only ones that we will consider. So R sub I, which is R sub 1 in this first equation, plus K sub 1, which is equal to a total shipping cost per unit of 5. And R sub 2 plus K sub 1 is equal to a unit shipping cost of 8, and so on and so forth until all the used boxes have a corresponding equation for each of them. After which, you solve for each value of the equations that you have just made. So, set R1 to 0 to begin. Afterwards, perform back substitute for the remaining unknown values. So here is how it goes. So we said a while ago where R1 is equal to 0. So using the first equation, since R1 is 0, K sub 1 now is equal to 5. And with K sub 1 equal to 5, we have R sub 2 equal to 3, and so on and so forth until all the values have been computed. Now with that, we apply them to the table. And the next step now is to calculate opportunity cost of increasing shipment through each unused cell. So to compute for the opportunity cost for each unused or non-basic cell, we have the formula. The cost of shipping from source I to destination j minus the sum of r sub I and k sub j. So applying them to each unused cell, we start with Manila to Taiwan, which has r sub 1 and k sub 2, which gives you a cost of 4 minus the r sub I, which was computed a while ago, to be 0, and k sub 2, which is equal to 1. That gives you a difference of 3. That gives you now the opportunity cost for that box. And next, for Manila to Jakarta, we have a shipping cost of 3 minus the r sub I, which is 0, and k sub j, k sub 3, which is negative 1. That gives you a difference of $4, and so on and so forth until the process is concluded. After which, check if there is any negative opportunity cost. If there is, select the cell with the most negative opportunity cost. However, if there is no negative value anymore, stop the process because it was already considered the optimal solution. However, in this case, there is a negative opportunity cost of negative 2 in the Davao to Hong Kong segment. And with that, we trace a closed path on the chosen cell and assign plus and minus signs alternately at each corner square of the closed path, beginning with a plus sign at the unused cell. So, just like the one in the stepping stone method, we start with the Davao to Hong Kong box and move to the right until we make a closed box. And then we add the determined units to all squares in the closed path with plus signs and subtract from all squares with the minus signs. So in this case, we add 100 units on the route Davao to Hong Kong and subtract 100 units from the route Davao to Taipei and add 100 units to the route of Cebu to Taipei and subtract 100 units from the route to Cebu to Hong Kong. And now we have this new table, and do repeat the process with the following equations on the used portion, used cells only, and compute for each variable and apply them on the table and compute for your opportunity cost and check if there's any negative opportunity cost. And in this case, we still have a negative opportunity cost on the Cebu to Jakarta cell. We proceed to doing the process again by forming a box around that portion on the used cells and getting finally our optimal solution with an optimal total cost of $3,900. And before we end our discussion, let us discuss some special issues in transportation model. So the first issue is the unbalanced problem, and it is a very common issue in the real world wherein supply is not equal to demand. So how do we solve this? We simply add a dummy row on the origin point if the supply is less than demand, and we add a dummy column on the destination point when supply is greater than demand. So just like in this example, since demand is lacking, we have to add a dummy column which is a destination point, a dummy destination point, just to ensure that supply is equal to demand. The other issue is degeneracy, wherein the m plus n minus 1 rule, or the number of occupied squares that have to be met, is not met. So the solution here is to place a 0 in an unused square and proceed to computing the improvement indices. Just like in this example, we need to have 5 boxes or 5 cells filled. However, only 4 cells are filled, which is a violation of the m plus n minus 1 rule. So to solve that, we simply put a 0 on the warehouse 2 to customer 1 cell to ensure that the rule is complied with before we proceed to our next few sets of computation.